So you're probably aware that we have 4 valves in the heart, and if you're not, that's completely okay. And you can see in this handy little drawing that I've placed on the left side of the screen that you can actually see all 4 valves at once in this picture, and that's kind of a unique view, and it gives you a way to visualize where the valves are in relation to each other. So let me help you orient yourself real quick. This is the pulmonic valve, and I'll abbreviate that PV. This is the aortic valve, AV. This is the mitral valve, and this is the tricuspid valve. So let's talk about murmurs for a second. So if you've been in the hospital, or you're familiar with cardiology, or maybe your grandma or grandpa has a murmur, maybe you've heard of some of the common ones, like, let's say, mitral regurgitation, or maybe aortic stenosis. Well, a lot of people get caught up with the regurgitation part, or the stenosis, and may forget what's actually causing or caused these problems. And so let's take a look at some of the things that actually cause valvular heart disease. So some valves can actually become calcified. And even though I'm drawing these little calcium ions as if they're ions and in solution, that's not really the case. And these calcium ions kind of go together with fat and cholesterol. And the last time you heard all those words together, unless you were talking about a Big Mac and a glass of milk, it was probably in reference to atherosclerosis. And so the process of valve calcification has actually been found to be very close to the process that causes atherosclerosis. And atherosclerosis is just the buildup of fatty and, over time, calcific plaques in the arteries of the body. So another cause of valvular disease is valve degeneration. And a lot of the times the degeneration is associated with connective tissue disorders. And all that really means is that you have problems with proteins that normally make up some of the structural components of the body. And there are these structural components in valves and some of the heart structures, and so that's why these valves can become dysfunctional. And so a classic connective tissue disorder would be something like Marfan syndrome. And the way I like to remember that is with a picture of good old Abe Lincoln. Now, this is not to say that Abe Lincoln had Marfan syndrome, but he did have some of the very typical outward features of Marfan, such as being really tall and skinny, having long fingers, and a really long face. So what else can do it? Well, bugs can do it. And when I say bugs, I don't mean an ant or a fly, but rather a pathogen or a bacteria or virus. And so these bugs can actually get into the blood, and since all the blood goes through the heart, then these bugs will actually see the surface of the valves in the heart, and they can either stick to it or cause an immune response or a combination of the two, and as a result you can get problems with the normal working of a valve. And so if you'll notice where I've placed all of these causes, they're actually all on the left side of this diagram. And so if you bear with me for a second, I'm going to kind of split the heart into left and right. And so here, I've separated the left side of the heart and the right side of the heart in terms of the valves. And the reason I've done this and listed all the causes on the left side is because, as a general rule, left-sided valvular heart conditions are much more common than right-sided valvular conditions. And the reason for this is pretty easy to understand. I like to think about it with a pair of shoes. So I have this pair of shoes that I love and wear all the time, and those get really worn out quickly. And then I have this other pair of shoes that I kind of baby, and I wear on the weekends or on special occasions, and those never get worn out. They last for a really long time. And so the left-sided valves are like that pair of shoes that I wear all the time. And so because the left side of the heart is the workforce that pumps blood out to the rest of the body, and it's pumping at really high pressures, every time the heart beats and goes through a cycle, blood is smacked up against these valves on the left side. And the right side, blood splashes up against these valves because it's at much lower pressure and is performing much less work. And so to illustrate the last two major causes, I'm going to come over to the right side of the screen. And so let me explain what this diagram is. We're actually looking at the left atrium here, the aorta here, and this whole thing is the left ventricle. And so for these two causes, the same left to right rule, meaning left more common than right, still applies. And so the first thing I want to talk about is annular dilation. So the annulus is really just this fibrous ring that supports the valves. And so you can see I'm circling those in right here for the two valves in this diagram. And so in a condition such as an aortic aneurysm, which is really just a ballooning out of the walls of an artery, you would have something that looks a little more like this. And as a result, it's going to pull the annulus this way. And so if we actually come over to the other diagram for a second and get rid of this line down the middle so we can see the aortic annulus, I can actually show you what that would look like in this view of the heart. And so instead of the annulus that I'm erasing now, as a result of this aortic aneurysm, now it's been dilated, and instead of the cusps coming together nicely, now maybe you have a situation like this, meaning that the valve does not close fully. And that circle that I'm drawing is the open area from the valve not being able to close. Now, how could you get annular dilation in the other valve in this diagram on the right? Well, what if the actual heart muscle dilates or expands? Well, now the annulus of this valve is being pulled this way, and so in a similar fashion, it's going to pull the valve apart. And over here on the left diagram, this would now look something like this. And so now you can see that this space in the middle, where my cursor is all open. And so you can imagine how that could cause problems with blood flow in the proper direction. And so the last major cause I want to talk to you about are ventricular attachment points. And so you'll notice in this diagram that we have these blue things right here, and these are called papillary muscles. And this is actually part of the left ventricular muscle, but they have a specific function, and that function is to hold these white strings here, which are called chordae tendineae. And I'm not really a professional at language, but to me that would seem to mean tendinous cords. And these tendinous cords are attached to the valve. And so the papillary muscles serve as a ventricular attachment to the valves via the chordae tendineae. And so you can imagine that if we have a rupture or break in a papillary muscle, or the same thing, a rupture or a break in a chordae tendineae, then this valve over here is kind of free to float wherever it wants. And so that can be problematic. And so these are most of the major causes of valvular heart disease.